All right, welcome back, Algebrists. Today is possibly the last day of the chapter, or the penultimate, just means one before the last day. And in 4.5, our focus in here is going to be on using more of those rational equations, but instead of just simply simplifying and adding in stuff, we're going to be solving these rational equations, which I would remind you, the Q is my shorthand. Solving rational equations. And let's jump in. When we start with these, we're trying to just extend the ideas that we have. To add two fractions together, they have to have a what? Common denominator, or a least common multiple of the denominator, but that's a terrible way to say it if we have a simple word. So the first thing that we need is to really understand what these things are. And I don't think it's going to be crazy. So we're going to define for ourselves in our first topic is really just what is a rational equation. Now, for this, if we think back to some nicer stuff, if I said I have a quadratic equation, could you write me a quadratic equation right now, do you think? Yes. 15 seconds. You don't even have to write it, but between you and your neighbor, come up with a quadratic equation. And I'm just going to write a couple on the whiteboard just to see if we do. Write me or say a quadratic equation with your neighbor. 15 seconds. I'm going to start calling on people. If it's quadratic, what does it have to have? X to some power. Good. There has to be an X squared in it. Okay, so checking it out. I just want to know what you've come up with. If it's not right, we'll clean it up and figure out why. But let's get here. Random numbers. Liam. X, just that? Just X squared minus 1? So, love part of it. Do I have a quadratic on the board? Is it an equation? What do I have to add to make this an equation instead? Say that again? I heard somebody say it. Equals, and I don't really care what the number is. It can be 0 or 5, doesn't matter. This is a quadratic equation. If I wanted another one, Lando, give me a different quadratic equation. What about the 5? You say plus? By what? Okay, so I'm cool with it. That is a quadratic, but is it a quadratic equation? Not yet. What does it need to be an equation? It has to have an equal something, and it doesn't have to be 0, Lando. That's traditionally, if we set it equal to 0 to solve it, we would. Just so this one winds up nice, I guess it's not. I don't care what the number is. Okay, what's a rational equation then? Those are both quadratics, right? Because it's a quadratic thing set equal to something. Could we do the same thing with rational expressions? For sure. So we're just going to say, by definition, super easy to define. It's pretty much these. This is just an equation. An equation with a rational, and I'm going to use this blackboard Q. And why Q again? So why Q, though? I agree that we use Q for rational because they're fractions, which are division, and it's a quotient. So an equation with a rational expression is all we really need. Now, these can be awesome, or they can be terribly, and they don't really get terrible to like work with, but they can be really nice or a little bit more involved. So that's it. A quick example of this, and we're going to do a bunch of them, is I want us, and we're going to start with some really easy ones, we're going to solve. Okay, so we're going to start, and I'm going to give you guys 2, and while you're working these 2 problems, I'm going to run down and get your factoring stuff for you. But I'm going to give you 2 pretty entry-level ones. I want you to work with your neighbors. I'll only be gone for just a second. We'll start with this. 1 over x plus, I don't know, 3. Right now, do I have a rational expression? Is there a ratio here with x in the denominator? So instead of ratio, what's the other word I can use? Is there a fraction with an x or a variable in the denominator? So this is rational right now. Like I could put it together and do x over x if I want. Up to you. Is it a rational equation though? Why? What's it missing? It's not equal to something. And now we have to have it equal to something. What do you want that something to be? Sure. Here's your first, and I'm going to bump it up a little bit. I want you guys to work through A for me first. And once you have A and you're confident in your answer, or you've asked questions if you're not, we're going to do one more. 1 over x plus 4 equals 3. Two pretty entry-level problems. I just want to see how you guys approach this before we talk about maybe more efficient approaches. I'm going to give you guys like 2 minutes. Talk it out. Try it. I'm going to do some printing real quick. Cool. Maybe we'll leave off and I'll go get the printing stuff. I have 20 minutes. We're good. Okay. Help me out here. I have no idea what to do on A. What'd you guys think? What'd you do first, Ronaldo? Okay. Ronathan says, let's take 3 from each side. Yeah, we're getting more creative. When I say one that you inevitably hate, just tell me and I'll stop saying it. Cool. All right. So I subtract 3 from each side. I'm good with that. And I think we get 1 over x equals negative 3. What now? What'd you say? Multiply by 1. So I don't know that we really need to. Now, here's a really important distinction. I'm very glad I heard that. When we don't have an equal sign, we can't multiply the same thing on both sides of an equal sign, right? So to keep balance, the only way we can do this is by multiplying by 1. Do I have an equal sign? So I can either multiply by 1 here, or since I have an equal sign, if I multiply both sides by the same thing, am I allowed? Sure. So instead of thinking about common denominator, which is natural because that's what we've been doing so much of, right now I'm trying to solve for x. Do we all agree? Where is it stuck? Like right now, where is x? It's in a denominator. When I solve, do I want it in the denominator? No. How do you undo? Like a denominator just means we're dividing by x. So you could do the reciprocal, and I like that language. But if all I need is this x out, can I just multiply by x? That undoes divide by x. If I do that to both sides of this equation, and we'll do it here, and I'll do it in this green color. I say x here and x here. I've done the same thing to both sides. Now, I do want to highlight, Mark, because this is what you said. Instead of doing this, is it any different than if I'd done this, and it's now just going to take me 2 steps? Like, if I do this, now I'm just going to multiply both sides by something to break the fraction anyway. Let's just do it here. What happens on the left? Shabba, shabba, they're gone. And what am I left with then? 1 equals what? Negative 3x. So if I just multiply it here, you mean? If I multiply 1 times 1 over x, though, Kennedy, what does it give me? I don't know, because I already have a 1 over x. What do you want me to multiply by? So that's what I did. Hold on, we're going to figure out your question because I don't understand. And it's a me thing, not you. Say that again. What do you think is happening? Yeah, like this one will give me 1, you think? This will still be 1 over x. And if my goal is to get it out of the denominator, did that do it? I'm not quite sure I understand your question, but do you agree that if I do this by 1, my x is still in the denominator? So my whole goal is to try to get it out of the denominator. If what I'm saying is not answering the question that you had, please let me know and I'll come talk with you specifically. Okay, we're 1 step away. Last little part. Divide by negative 3. And when I do that to both sides of this, what do we conclude we get for x? Negative 1/3. Now, just remember, I don't care where you put it. I know where I prefer to have the negative. You can put it in the numerator. You can put it in the denominator. You can put it out front. I hate the denominator, but if that's what is more natural for you, you can do it. Okay, how could we be confident in our answer? If I do 1 over negative 1/3 and I multiply by the reciprocal, it winds up being negative 3 plus 3, which is, I'm good. We checked our answer. If I want to check it, if I do 1 over negative 1/3 plus 3, then I do indeed get 0. Cool. Okay, is this problem doable? Did anybody do it differently than this? Okay, so I'll come look at yours. On B, suggestions. Same thing. What do you mean? What do you want me to multiply both sides by? This time, because I'm solving for x and it's stuck down here, I think that I agree with that. I can multiply both sides by x plus 4. Now, I'll do the left because I'm kind like that. So 1. What's the right? So I'm okay with 3x plus 12, but let's think this out here real quick. If I just write this first, what am I trying to solve for? Now, if I compare this right now and I said, let's get x alone, what's the next step? So instead of distributing, what if I don't want to distribute? Now I can just divide by 3 here. Now, this is what I would recommend doing, and I'm going to switch color so it stands out. But I want to look at the alternative because if most, I got several people, I can't say most because like 3 people said it, but I heard people say distribute, and I just want to compare this. If those divide out, what am I left with? 1/3 x, or 1/3 equals x plus 4. Now can I solve it for x? I'll subtract 4 from each side of this equation. How should I write 4 on this side? 4 over 4 would be 1. Can I call it 12/3? And somebody out there, and I can see it, somebody's going, why on earth would you do that? So let's not yet. I get 1/3 minus 4 is equal to x, right? Now, this is an answer, but we can clean it up. Why can't I combine these yet? So this is really over what right now? 1. Give me a clever choice of 1 that I can multiply this by to ensure that we can add these things. 3 over 3. And we see that a couple steps down the road, we get 1/3 minus, what's this? 12/3 equals x. And I'm going to work this way just so it stays on the screen. Can these combine now? X must have been what? Negative 11 over 3. Now, so, and did you distribute? And I just want to look at this. Now, for these, it's okay if you want to distribute, but I really want to think about what happens if you distributed. And how many of you guys did distribute when you did it on your own? Did you still have to divide by a 3 and factor and divide? Like, you still have to do all the same stuff. There's no benefit to multiplying and foiling if we can just divide it away. Save a little bit of the work. And it's not wildly hard work here, right? If you distributed, you're going to get the same answer. It's not crazy. But if you get a bunch of stuff multiplying, like x plus 2 and x plus 3 and x plus 5, I think I could convince you a little more that you probably shouldn't actually multiply them all out. Okay, looking at these, are these the only approaches that we could take? Maybe. Let's try a couple more before we move on. Huge issues here anywhere. Does this feel like 7th grade stuff? 8th grade? Okay, should we bump it up a little? Good. On C, we're going a little bit crazier with it here. Just a skosh. Or a lot of skosh. We'll see. Okay, don't want to make it too crazy. Love it. Here we go. C for you guys. 5x divided by x minus 2 plus 7. And I lied. I'm going to make this equals. I'm sorry, I have a typo. I'm terribly sorry. Not 5x over x minus 2 plus, but equals 7 plus 10 over x minus 2. It looks like it's a little bit bigger of a problem. Now, I'm adding the parentheses just so they stand out a little bit more clear. It is a bigger problem. I'm going to let you guys play around with this, and then we'll come back together in about 90 seconds. Okay, so I heard a whole lot of stuff there. We're going to come back together. Perskovia, I heard you say something. Okay, can I subtract just this piece to ensure that all the x's are on one side? Yeah, seems like a reasonable approach. Is it the only thing that I can do? No, but it's, I think, a reasonable thing. And it looks very much like what we did just now. If I subtract this from each side, and I'm just going to say minus, and I actually do the whole thing, x minus 2. And this side, I'm going to have a minus 10 over x minus 2, because I do the same thing to both sides, right? Okay, what's really nice about the left side, I'm going to write it out the long way here. 5x over x minus 2, and what am I subtracting from it? 10 over x minus 2, and that's now all equal to what? 7. Now, I've written more than I think I need to. What can I possibly have done, or can I do now to make this look a little bit nicer? So careful. I heard like 4 different things, and I just want to make sure I can hear them all. I heard something from you. I didn't. What did you say? I noticed, and they noticed, a common denominator. I heard some other answers, though. I heard somebody say cancel, but I don't know where you want me to cancel. Nor who. So is there one up top in the numerator and one down below in the denominator? So I'm not going to divide them out. I can't do that. Right now they're common. I'm going to use that to my advantage. Can I write this as a single fraction? Okay, so I'm fine with this if this is the route that we're taking. Now what? I have x's in the denominators, which even though we all love fractions, like deeply, can we agree that not fractions is probably nicer than fractions? So right now, my fraction has me dividing by x minus 2. What undoes divide by x minus 2? We multiply each side by the same thing, and I'm going to specifically multiply by a value that busts the fraction. Like, that's the whole goal here. Is that what Miss Jarvis used as fraction busting? Is that language common to you guys? Okay. So what happens with these on the left now that there's multiplying and dividing by x minus 2? They're gone. And so nothing cancels there yet. We're just going to have to deal with it. And let's just see where it takes us. 5x minus 10 is now equal to, and we'll make a decision here. I'll write it without doing it first. I'm only going to distribute if I have to. When I do this, are all the x's on the same side anymore? Are they? Can I make them? But I can't just move stuff now because multiplication happens before addition and subtraction. So what must we do? If I want to move the 7 and the x around, I have to distribute. So we'll go distribute in. And we get 5x minus 10 equals 7x minus 14. And as soon as we get here, does it feel like a hard algebra 2 problem anymore? What's it feel like? Like algebra 1, I think. What do you want me to do? X is on the right or left? Left is not what I would do, but I'm good with it. So I'll subtract 7x, and I'll add 10. For those of you that are doing it the other way, if you subtracted 5x, I agree, add 14 to the other side. Keep up with it. Let's make sure we get the same thing. And let's see, how many x's over here on mine? Negative 2x equals negative 4. And where do we end up? So what's negative 14 plus 10? Somebody said what at that part of it? It's negative 4. And now divide by what here? And what do we get for x? 2. Now, anything weird about this that shakes out? We claim that x equals 2 was our solution, right? Now, mathematics is pretty good, but we also have to think about these a little bit. What is my issue with this as my answer? Because what should we always do with our answers? We should plug it in to check, and as soon as we do that, what do we see happens? It divides by 0. So can we use this x? So I'm going to make that comment super duper clear. I mean, it's right, but we're going to get there. It doesn't work for this problem, though. And this is a unique situation. What's up? Okay, for this, I'm going to make this comment. I think you guys should too. When we check with the original, we divide by 0. Now, is that allowed? So, bummer. So the answer that we found mathematically, because we simplified as we were going, it works. But does it really work? So this was the only possible answer we had, right? Did I make a mistake somewhere? So where's my mistake then? Or where's your mistake?
Well, the first thing I did was I canceled out the x minus 2, so I multiplied them on both sides.
So I like that idea. We're going to come back to that. we'll look at this problem again. Because that's what I was hoping that people would do, but you have a mistake in yours. I'm confident of it. Okay. When we check with this, we divide by 0, which means this answer doesn't work, right? We only found one answer in this method. And we'll only find one answer in your method, I assure you. But we have an answer that doesn't work. An extra answer that just shouldn't be there. Have we ever used that language in here? In this situation, I think we have, but I could be wrong. We have what is known, in this case, an extraneous. And I'm going to focus on extra, like it's not as fitting here, but we have what is known as an extraneous solution. Now, what that means, we found mathematically the x value that works, quote unquote, works. But does it really work? No. Now, since this was the only option that we had and we saw that doesn't really work, what do you think we conclude about this particular equation? We had one answer, but now it doesn't work. How many solutions do we have? No solution. We have some weird situations from time to time, and I know we've used this language. Gosh, that clock gets me over and over. It's wrong. You guys remember solving systems? When you solve something like this, and we don't have to write all this down, but we've had systems of equations where it had parallel lines. And if you find an answer, or when you're working the problem, you eventually get down to somewhere where it says 2 = 5 or something nonsense like that. And we find an answer, but it just doesn't work because it's not true. We've already dealt with extraneous solutions. We're just seeing them expressed in a different way here. Now, starting class on Monday, and it looks like we're going to need one more day. We're going to look at the same problem with your guys' method, because that's what I really want to build to. This is the natural way to do it. There's a better way. The good news is that even though we didn't get book homework, I'm going to come around and distribute to each and every one of you this wonderful factoring homework.